Hi, and welcome to this quick guide to the Danube Indeet Model, or DIM. DIM is a Windows desktop tool that helps you design and analyze integrated energy systems, solar, batteries, EV charging, and green hydrogen, and figure out what's actually worth building. The clever part is that DIM doesn't just tell you what to build. It runs a full optimization that decides how big each component should be and how to operate it, hour by hour, to maximize profit and minimize cost. One quick note before we start. The tool uses an internet connection for location-based solar and weather data, so make sure you're online for the best experience. Let's build a real example together. When you launch the application, you'll see the Welcome window with three options: create a new project, open an existing project, or check the user manual. Let's click Create New Project. I'll enter a project name, let's call it My Project, and if I want, I can change the folder with the Browse button. Then I click Create Project, and our new project opens in the main window. DIM saves everything in a single .indeet file, so your whole study stays in one place. Now, let's add a scenario. In the sidebar on the left, I click Add New Scenario. A default scenario called Scenario 1 appears. I'll expand the scenario and click System Structure. Each scenario has two parts: System Structure, where we design the system, and Results, where we'll see the optimizer's recommendation later. The main window now shows the system configuration interface. This is where the work happens. A new scenario starts with all components already selected. As you change the selection, watch the system diagram update live so you always see how the pieces connect. For this first example, we'll keep it simple and use four components: the electrical grid connection, a PV system, a battery energy storage system, or BESS, and a fixed electricity consumption. So I'll deselect the components we don't need right now, like the electrolyzer and EV chargers, and make sure L-grid, PV, BESS, and L-consumption stay checked. Quick word on the BESS. The battery lets us store cheap or surplus solar energy and use it later, instead of selling it back to the grid at a low price. The optimizer will decide the ideal battery size and exactly when to charge and discharge it. Now let's enter parameters. Good news! DIM pre-fills sensible defaults everywhere, so we only touch a few fields. First, location. I'll expand the location section and search for Zagreb. Then select Zagreb in the municipality dropdown. I'll verify the coordinates and the country. Location matters because it drives the solar irradiance data, and other location-specific values DIM pulls in automatically. Next, the electrical grid connection. This defines our electricity prices and connection conditions. And because we picked a location in Croatia, Croatian tariff models are now available. I'll expand the grid connection node. I'll use predefined connection type. I'll check Grid Connection Already Exists and set the existing connection size to 270 kilowatts. This represents the connection we already have. Then I'll expand Electricity Supply, and for Use Predefined Supply Models, choose Predefined Supply Pricing Model. That's our buy and sell electricity prices set in just a few clicks. The grid lets us buy power when the sun isn't shining and sell surplus back when it pays to. Now the PV system, our solar generation. I'll expand the photovoltaic system section and click Add New Array, then Done in the pop-up. A default PV array appears. The only thing I'll change here is the available area. I'll enter 1,000 square meters. That tells the optimizer how much roof or land we have. DIM fetches the real production profile for Zagreb automatically and decides how much of that area is actually worth filling with panels. On to the BESS. Here's the nice part. The default battery parameters are already filled in with reasonable efficiency, depth of discharge, and cost values. So for this example, we can simply skip it and let the optimizer size the battery for us. Now, our demand. I'll expand electricity consumption, click Add New Consumer, and click Done. For the building type, I'll pick large hotel. You can choose realistic load profiles for many building archetypes. Then I'll set the annual electricity consumption to 1,000 megawatt hours. This gives the model a realistic hour-by-hour demand to satisfy. Almost there. Let's set the financial parameters. For this example, we'll apply a subsidy. I'll click Apply Subsidy to All Components and enter 50% in the Investment Subsidy field. Now, half of the upfront investment is subsidized. This is also where you'd set things like project lifetime, discount rate, a maximum payoff period, or an investment cap, but the defaults are fine for us today. With everything configured, I'll scroll to the bottom of the System Structure view and click Run Optimization. A progress indicator appears while DIM builds and solves the optimization model, sizing every component and planning its operation across the whole year, all at once. When it finishes, a Results node appears in the sidebar under the scenario. Let's open it. Clicking Results brings up the full picture, the optimal system configuration, its operation, and the financial indicators. The diagram at the top lights up only the components DIM recommends investing in, so at a glance, you know what's worth building. Right below it is a plain language recommendation. For example, how many years until the investment pays off, and how much profit it makes. If it doesn't make financial sense, DIM just tells you it's not recommended to invest. Then the key recommendations, the optimal sizes, like how many kilowatts of solar and how big a battery to install. The operational overview has interactive charts showing energy flowing through the system over the year, solar coming in, the battery charging and discharging, and power bought and sold from the grid. You can hover and zoom into any moment. And the financial specification is the bottom line. CapEx, operating cost, revenue, and profit, comparing your current situation against the optimized one, plus metrics like payoff period, NPV, ROI, and IRR. You can also export the whole thing as a PDF report. Here's an important detail. Once a scenario is optimized, it becomes locked. Its inputs can't be changed. That keeps your results trustworthy. To test a different idea, we duplicate it. I'll right-click the scenario in the sidebar and choose Duplicate. Now I have an editable copy to experiment with. The user manual suggests a great first experiment. Change the subsidy from 50% to 0% and rerun. You'll see exactly how subsidies affect whether the investment makes sense. But let's make it more interesting and add the green hydrogen value chain. In the duplicated scenario's system structure, I'll select a few more components. First, the electrolyzer. This uses electricity, ideally our green solar power, to split water into hydrogen and oxygen. DIM automatically attaches a water supply and a hydrogen storage tank for us. Next, and this is the exciting part, hydrogen sales. This lets us actually sell the hydrogen we produce to customers at a price we define, turning the system into a revenue-generating business. You can even inject hydrogen into a gas pipeline if that's available at your site. And if we want to squeeze out even more value, DIM offers extras like EV chargers with vehicle-to-grid and recovering waste heat to sell as well. In the electrolyzer block, I can choose predefined electrolyzer with default values for efficiency, power consumption, and in hydrogen sales, I define how much hydrogen customers want, how often, and at what price. Then I run the optimization again. And now, DIM optimizes the whole chain together. Solar charging a battery, powering an electrolyzer, making hydrogen we store and sell. We followed the simple PV plus battery example from the Getting Started guide, then extended it into a full green hydrogen plant that sells hydrogen. And in both cases, DIM told us exactly what to build, how to run it, and whether it pays off. From renewables and storage to hydrogen, oxygen, waste heat, and EV charging, DIM turns a complex energy idea into a clear, profitable plan. Thanks for watching. Now, go build something.